Welcome to lesson 6.2, Solve Systems of Linear Equations Continued. So let's take a look at our objective for today. Our objective is I can solve systems of equations graphically. And this is exactly what we did in the last lesson, only now, instead of having our equations in y equals mx plus b form, we're going to have to solve for y and isolate that variable. Okay, so just a quick recap. A system has one solution. So remember, it has one solution if the lines intersect at one point. That one point is our one solution, okay? So the xy value has to satisfy both equations. That's where our check comes in, where we have to plug in our x value and plug in our y value and make sure that it satisfies both of them, okay? So let's see here. So then, well, if the lines intersect once, then that means they have different slope and they have a different y-intercept. Okay, let's take a look at the second one. System has no solution, so absolutely none. That means that the lines are parallel. Right? There can't be any solutions if they never touch. They never intersect. And what that means is that they have the same slope. They're going to be going up at the same constant rate, but they're going to cross the y-axis at a different time. So they're going to have different y-intercepts. Okay? Last one, have infinitely many solutions. Well, that is if they are the same line, right? When graphed, they're the exact same. So no matter what point I pick, they're going to be on both of the lines, right? So what that means is they're going to have different slope. Oh my gosh, Ms. Wall, absolutely not. Pay attention, guys. Okay, same line, they're going to have the same slope and same y-intercept. Oh, so same slope, same y-intercept. Okay? Whew. Okay, infinite, same line, same everything. Okay, flip the page. Sorry about that. So on your paper, you'll notice that you don't have these equations written down. I need you to write those down for me. Okay? So notice here we have 2y equals 4x plus 2 and 3y equals 6x plus 3. It says graph the system of equations using the slope formula. So that slope formula that we're referring to, remember, is y equals mx plus b. That's what I talked about a couple of minutes ago. We have to have y isolated by itself before we can graph it and determine the solution. So if we look over here, y is not by itself. Y is being multiplied by 2. The opposite is to divide by 2. So I have to divide each piece by 2. When we do that, we get y equals 2x plus 1. Okay, so let's graph that one. Here, this means that our slope is 2. So that means we're going to go up 2 over 1, remember? And our y-intercept is our b, which is 1, which means we start at 1 on the y-axis. So we're going to start at 1, mark our point. And then from that point, we're going to go up 2 and to the right 1 because it's positive. So go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And I'm going to take my ruler, draw a line through those points. All right, so that's the first one. The second one, we have to get y by itself as well. There's a 3 attached to it. So the opposite of multiplying by 3 is dividing by 3. So we're going to divide each piece by 3. When we do that, we get y equals, well, 6 divided by 3 is 2x, plus 3 divided by 3 is 1. Whoa, wait a second, what do we know? This equation is the same exact one as that one, simplified, right? So the same exact equation, which means they have the same slope, same y-intercept, so there are going to be infinitely many solutions. Right? Do I need to graph this one? I already did, right? I don't have to graph it again. It's right there. So we have infinitely many solutions there. Notice same slope, same y-intercept. Okay? All right, let's move on to the next one. So it says graph the system's equations using the slope formula. Again, you have to write these two equations down for me. It's y plus 2 equals 2x and x plus y equals 1. So after you have those two equations written down, we need to get them in y equals mx plus b form. So right now here we're adding 2 to y. The opposite of adding is subtracting 2 from both sides. When we do that, these 2's cancel, but we get y equals 2x. Remember, I can't take away this 2 from the 2x because they are not like terms. So it's going to be 2x minus 2. The next one down here, I have to get y all by itself. How do I do that? Well, I'm adding an x. The opposite of adding is subtracting x. Those cancel. We get y equals, well, 1 minus x. I can't combine them because one has an x and one doesn't. It's going to look like this. Okay, so now we're going to graph these two lines. But notice one thing first. Notice that our slope, or our m of the first one, is a 2, right? So our slope here is 2 over 1. Our b, our y-intercept for this one, is negative 2. That means it crosses the y-axis at negative 2. Looking at this equation, it looks like my slope, my number in front of my x, there's nothing there. Remember, that's really a hidden 1. So I have a negative 1 for my slope here. So it's going to be negative 1 over 1. And my b, my y-intercept, is the number without the x attached, which is positive 1. So if I compare these for a minute, before I even graph them, I notice here that I have a slope of 2 and a slope of negative 1. This one has a y-intercept of negative 2. This one has a y-intercept of 1. So because everything is different, we know that there is going to be one solution. We know that they're going to intersect, okay? So just by looking at these, we can observe that. Now let's graph it. So looking at this first equation right here, we start at negative 2 on the y-axis because that's our y-intercept. And then our slope is positive 2 over 1, so we go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And we are going to graph that line. Like so. All right, now our next one, the second equation has a slope of negative 1 over 1, but our y-intercept is 1. So we're going to mark the y-axis at 1. And then we have to go down 1 to the right 1 because our slope is negative. So down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And I already noticed the point in which they intersect, so those 4 points will be plenty. Let's mark it. So it looks like these 2 points intersect at the point 1, 0. So the solution to my 2 equations is 1, 0. So now let's check. So I noticed last time that we're really slacking on the check, so we need to make sure that we're 100% correct, that this is the correct solution, because we all have graphing errors sometimes, even me, okay? So what that means is we're going to take our 2 equations right here. I want us to take our original, because maybe we accidentally added or subtracted wrong, right? So I have these 2 equations, and I'm going to plug in when x is 1, y is 0. So y is 0 plus 2 equals 2 times 1, which is my x. Right? So 2 equals 2. That works. So I know that this is a solution to this equation. Now let's check the next one. I have 1 is my x plus 0 is my y equals 1. 1 equals 1. That also checks out, which means that the point 1, 0 is in fact a solution to these 2 lines. Okay? All right, now I want you to flip the page for me. I want you to try number 3 on your own. So I want you to take a moment, write down these 2 equations, y minus 2x equals 1, and 3 plus y equals 2x. Remember, using the slope formula, you need to get it in y equals mx plus b form. Get y isolated by itself. I want you to graph the solution and tell me how many there are. Remember to think to yourself, too, after you get y by itself, compare their slopes, compare their y-intercepts. That'll tell you how many solutions they have, right? So go ahead and take 3. I'm going to have you enter your solution of the 2 equations onto Edpuzzle. So when you're done, make sure you enter this on Edpuzzle. Okay? All right, welcome back. Let's take a look at number 4 now. So number 4, we have 2 different equations. I want you to write these down for me. The first one is negative 2x plus 3y equals negative 6. The second one is y equals 2. So the first thing we need to do, remember, is to get y all by itself for this first one. We need to isolate it. So I'm going to do my work over here on the side. So here I have a 3y and negative 2x is being added to it. So the opposite is to add 2x to both sides. So we have 3y equals negative 6 plus 2x. Right? Now I need to get this y by itself. The opposite of multiplying by 3 is dividing by 3. So we're going to divide by 3 on each piece, remember? So we have y equals negative 6 divided by 3 is negative 2 plus 2/3 x. Now I could divide 2 by 3 if I wanted to. I get 0.6 repeating. That's kind of strange. But because it's the slope, I'm going to leave it as plus 2/3 x because that tells me I'm going to rise 2 and run 3. Okay, so I'm going to rewrite this by using the commutative property. So I have it in y equals mx plus b form. I just switched the order of these two in the equation. Okay, so now looking at this equation and my second equation, we see that here we have a slope of 2/3. Here we don't have any x. So our coefficient is a 0, which means here we have 0 slope. Right? Over here we have a y-intercept of negative 2. Here we have a y-intercept of 2. So the y-intercept is 2 here. So 2 and negative 2 aren't the same. So they have different slopes, different y-intercepts. That means we're going to have one solution, right? So looking at this one solution, let's graph these two lines. So if I look at my first equation that I solved for y equals, our y-intercept is negative 2, like we said before. So we're going to mark negative 2 on the y-axis. Now our slope is 2/3. That means we go up 2, and because it's positive, we go to the right 3. 1, 2, 3. Up 2 to the right. 1, 2, 3. And then we connect those points. All right, perfect. So now that we've done that, let's graph the second line. So remember, if it's a y equals and it's a number, that means it's going to be a horizontal line. It's going to have 0 slope, so it's going to go straight across this way, and it's going to cross the y-axis wherever the y-intercept is, whatever your number is. So here our number is 2, so we have to go up to 2. That's where it's going to cross the y-axis because it's the y-intercept. And a 0 slope, remember, is completely horizontal. So we're going to draw a horizontal line here. And we see that they intersect at the point 6, 2. So our solution is 6, 2. So now that we have this, let's check to make sure that it's right. So I have my two equations to begin with, negative 2x plus 3y equals negative 6, and y equals 2. Well, looking right away, our y value here is 2, so I know that it satisfies that, right? Who cares what the x is? Now for this one, remember we plug in 6 for x and 2 for y. So we have negative 2 times x is 6 plus 3, y is 2 equals negative 6. Negative 2 times 6 is negative 12 plus 6 equals negative 6. Well, what do you know? Negative 12 plus 6 is negative 6, so it checks out, which means that this is a point on that line and this one as well. So we know that we've done so correctly. Okay, flip the page for me. All right, what I would like you to do now is work on 5 on your own. I want you to write down these two equations. Negative 4x plus 2y equals negative 10, and y equals negative 2x minus 1. Remember to get this first formula into y equals mx plus b form. All right, compare their slopes, compare their y-intercepts, graph them. I want you to enter the solutions to the two equations onto Edpuzzle for me when you're done. Make sure to get your hand, Miss Wall. Make sure to raise your hand to get it checked, please. All right, welcome back. Let's take a look at 6. 6 I also want you to do on your own. The two equations are 5y minus 5 equals 10x, and y equals 2x plus 1. Okay, you're going to have to, again, get this first one in y equals mx plus b form. Graph them. Remember to compare your slope and your y-intercept. You are also going to, in the end, enter the solution to the two equations onto Edpuzzle. Okay? All right, have fun. Bye.